Hello everyone. Today I'm going to discuss my major project topic, that is enhanced DenseNet neural network model based on improved UNet for rice leaf disease identification. I'm going to tell you how the complete model works in a step by step manner. So first of all, let us consider a rice and how can you retrieve or predict whether the rice leaf has a particular disease or not. So we can use DenseNet neural network with the help of convolutional neural network for these disease identification. So how can it work? So basically the DenseNet neural network utilizes dense connections between layers through dense blocks, and DenseNet can increase the depth of the convolutional neural network. So in DenseNet we get closely connected CNN, and CNN is basically used for image classification, and CNN when used with ResNet, that is similar to DenseNet, it is addition to two different parameters. One is the previous one and one is the DenseNet one. So in the previous output can be used as the current input, and in DenseNet all the previous output as in input can be used for the future layer. And why we are using DenseNet particularly in our project? Just to improve the accuracy by vanishing the gradient in high level neural networks. And the reason is pretty simple: to maintain a long distance between the input and output, and the information vanishes before reading its destination. So suppose let us take an example that we have L layers equal to L, and we can derive a formula as L into L plus 1 whole divided by 2 as our DenseNet layer, and we can train more than hundreds of layers in this model. And how to identify whether a particular rice leaf has a particular disease or not? For that we need to identify a particular region, that is a lesion or the damaged or abnormal change in the tissue or injury or diseases in the rice leaf. So how the DenseNet neural network works in our project? So first of all, we can give a straight point at lesion feature extraction of interest using the extraction algorithm, where we can use DenseNet classification method for accurate recognition of lesion feature using extraction maps. And how can we proceed with that? We need to have ROI, that is the region of interest extraction algorithm, which can highlight the lesion area of rice leaves. So we need to focus on the neural network classification. And how can we go ahead with the classification or comparison? So in a single rice disease classification model, the classification model is combined with the ROI extraction model, which can improve the recognition accuracy of rice leaf disease classification. And why we have taken this project? So basically in my mindset it was that rice is majorly consumed in India as well as in China, and if we combine both of them, it is more than how much it is consumed in the entire globe. And rice leaves directly affect the quality and yield of rice, and which can cause rice leaf diseases like brown spot, bacteria blight, leaf blast, and we can improve them using the transfer learning techniques. There might be certain classifications and control of disease that are crucial in rice cultivation. So what we previously used to have, we used to have a traditional method where we had manual observation and identification of the leaves, where we had labor intensive, extensive experience, both used to be on the same place simultaneously. And for plant leaf detection, we need the leaf images. From that we can have deep CNN, which can do image classification and detection, and crop disease detection. Rice can do the crop disease detection with the help of transfer learning method. And how we can proceed with the algorithms or models? EAFSO can be associated with DCNN LSTM, which is used to identify the rice disease. There is another technique that is called as the migration learning technique, which can be used for the identification of rice diseases. We have the AlexNet method model that is used to pre-train the ImageNet designed on a fully connected layer. And what are the benefits? They are used to save the time, they are used to save the labor cost. And what's the novelty in our project? So we are using improved UNet for ROI, that is the region of interest extraction in our project, which allows the computer to automatically select out the region of interest and identify the most appropriate image that provides more information than other images. So what are the parameters which we are using in the project? One is the dice coefficient, then is accuracy, prediction, precision, recall, F1 score, AUC, confusion matrix. And how we will make sure the project is completed on time. So for that I have made a complete workflow from start to end, and we have also implemented some parts of the project. So let me tell you how the workflow would go. So first, rice leaf images from Google or any other website of 4 different types. Then we have to train the sample collection by using separate shouting after collecting the rice leaves in the field. So how we can ensure a balanced distribution of the data set? So first of all, we have to train the samples to be generated using the Gaussian generative adversarial network. Then we have to add it to the data set. The images then are stored in the PNG format. Then the parameters must be associated only if the rice leaf image resolution is high. And what can be the side effects? There might be increased computational load or a long training time. So these might be the side effects that might happen or we can see while working on the project. And how can the samples be treated? We can use random image enhancement, where we can add random rotations, random zoom, random shifts, and shear transformation for identifying disease in the leaf. And the disease areas will be annotated by label MC to get the masks used by ROI extraction model training. So deep learning will be conducted in Python 3.8 with TensorFlow 2.4 framework with GPU acceleration. How the actual flowchart will look like: ROI extraction model, then input of the rice leaf images, then locate and output disease areas, which will have both input and output. Input will have segmented disease areas, output will have the extract of disease types. And why we are using UNet in this project? Basically to create pixel level masks for each object in the images. For now, the explanation till here would be more than sufficient. Let's move towards the coding part that we have deployed in Python.